Okay, here we go. Another video. This one's going to be over graphing lines. We're going to just go through some quick refreshing what you've been taught in the past, possibly seeing this stuff for the first time in a long time. So here we go. When we graph lines in this class, for now, I think focusing on slope-intercept form is probably going to be the easiest thing for us. So slope-intercept form is either y equals mx plus b, or of course we saw this in our last lesson, it might be f of x equals mx plus b, where y and f of x, for the purposes of this class, are pretty much interchangeable. Things that we need to remember, I always start with the b, so I always graph b, which is our y-intercept. First, and then we're going to graph the rest using slope. So m is otherwise known as slope, which a lot of times you see written as rise over run, or like change in y, delta y, which delta means change in y over change in x. Or like if you want to get super extra with it, it could be like y2 minus y1 over x2 minus x1. All of those things mean the exact same thing. So we can just say rise over run. So what does that look like? Let's look at this first problem here. I am going to start with that b value of -1. What that means is that on my y-axis, this line is going to start at -1. -1 on the y-axis is right down here. And then I'm going to use the slope to graph the rest of the line, that m value, which is in front of the x, right? So if we go back over here, the m is connected to the x, and the b, that y-intercept, is our constant. It has no variable attached to it. So whatever's attached to the variable, that's going to be our slope. So in this case, that is -1 over 3. You'll notice that I put that negative up there. Technically it doesn't matter where you put that negative, but the negative being in the numerator is going to be a lot more, it's going to be easier to understand. So whenever I start thinking about this as rise over run, in my mind, I'm thinking down 1, right 3. So that negative means that we're going to go down 1, and that positive 3 means that we're going to run or go right 3. So from the point that I've got here, I'm going to go down 1, right 3, and that's going to give me my next point. Down 1, right 3, and then you just kind of repeat that pattern. Down 1, right 3. Down 1, right 3. Or you could do the opposite of it and go up 1, left 3. And that's going to continue. You know you're doing it right if it creates a line. Now, some things that you'll notice. Maybe we can make a side here. Negative slope. Your line is going to go down and to the right as you go kind of like from left to right. Whereas if you have a positive slope, your line is going to go up and to the right. So negative slope, this one is -1/3. So you can see that line is going down as we go from left to right. Up 1, left 3, up 1, left 3, and we've got everything all drawn. Do your best to connect the dots. And that's your line. That's it. That's the problem. That is what -1/3 x minus 1 looks like. So again, we're starting with the y-intercept and then using the slope to graph everything else. Let's look at one that's a little bit more complicated. This is written in what's known as standard form. We are going to do some algebra, use some properties of equality to get that y isolated by itself. So just hang with me as we go through a little bit of math here. I want that y by itself with me, which means all that other stuff with it has got to go. First thing I'm thinking about doing is, can I add or subtract? So if we recently learned the order of operations, when you are trying to like undo things or solve something or isolate something, you tend to go in the reverse order of operations. So I'm actually going to be looking for something I can add or subtract, and that is whenever I want an entire term to go away. So if you want like an entire term, we want this y to be by itself on the left. So if we want to get rid of an entire term, you're going to add or subtract. If you want to get rid of just a coefficient is something that's like attached to a variable, you're going to multiply or divide. I want to get rid of this entire 4x, so I'm going to start this by subtracting 4x from both sides. All right, this is like both sides of the equal sign, so I'm going to minus 4x. Negative 4x minus 4x equals 0. They end up canceling each other out, leaving me with a minus 9y. And then over here, I'm going to actually write this as minus 4x and then a positive 27. So that plus 27, that 27 just becomes a plus 27 since it's positive. And I'm writing the x first just so it can kind of match that mx plus b form. Now I need to get rid of a coefficient. So I got to divide, because this is negative 9 times y. We're going to undo that negative 9 times y by using division. So I'm going to divide by negative 9. And here's what you got to do on this side. You actually have to divide everything by negative 9. So whenever you multiply or divide, it gets applied to everything. Here's how this works. Here's why this works. Negative 9 divided by negative 9 ends up equaling 1. So that's not just a slash there. This is like a 1. Let's use a different color. That becomes 1. Negative 9 divided by negative 9. Something divided by itself equals 1, which means I have 1 times y, which is just y. On the other side, I've got negative 4 over negative 9. Now, a negative over a negative I can rewrite as a positive, and I'm not going to write this as a decimal. This is slope. It's beneficial for me to leave it as a fraction. So we're going to change that to negative 4 over negative 9. We're going to change that to 4 over 9. And we're not going to change it to like 0.44444. We like this fraction because now I can say the rise is 4 and the run is 9. And then 27 divided by negative 9, that's a nice one. 27 is divisible by 9. You can use a calculator if you needed to, but that's going to end up equaling 3. But since it's a positive divided by a negative, it's going to end up equaling a negative 3 or a minus 3. And now I can finally get to the part where I graph this. My rise over run, I'm thinking about this as a rise of 4, so like up 4 because it's positive, and then right 9 because that 9 is positive. But we're going to graph that b value first. That b value is negative 3. I'm going to put a dot at negative 3, and then I'm going to graph that slope. Up 4, 1, 2, 3, 4, over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Counting carefully, that puts a dot right here. And then you can do the opposite. You can go down 4 and then left 9, and we're going to end up way out here. I'm going to try my best to connect these dots. And that's it. So I started at negative 3 and then used the slope to graph the rest. The last problem on the notes, write an equation for this. I should probably say write the equation for the line graph below. And these are going to be not so bad because you can just look at it and figure it out. So for example, if you are trying to fill in y equals mx plus b, b is right there. It is your y-intercept. So if your y-intercept is at 3, you know that your b value is 3. And then you can create what's known as a slope triangle to figure out what your slope is. Like, how do you go from b to the next point? So I've got my y-intercept here, and the next time I get a nice intersection, seems to be here, and by intersection I mean like it's at one of the grid marks, right? And here's another one right here. This line passes perfectly in this kind of like center of this plus grid mark area here. Okay, So I create a slope triangle. Like, how do I get there? Going rise and then run. Rise and then run. Rise and then run. And you can just count those units. 1, 2. So that's a rise of 2. 1, 2, 3. And a run of 3. So if your M value is rise over run, you can look at these slope triangles and see that we go up to right 3. So those are going to be positive, right? Our line is going up and to the right, so this is a positive slope. And we just plug those things in to get our final answer. So instead of y equals mx plus b, my m is 2/3. So mx and then plus b would be 3. And that's going to be your final answer right there. So sometimes you're going to be writing the equation, sometimes you're going to be graphing the line. And yeah, that is it. That's what 1.1 looks like. I hope this video is helpful. I'll see you in class.